Today I'm going to explain what is differentiation and what are the techniques. So first of all, what is differentiation? Differentiation is a mathematical process used to determine the rate of change of a function with respect to a variable. In a simple word, it tells you how fast something is changing. When we use differentiation to find speed and acceleration, study growth, determine maximum and minimum values, analyze how steep a graph is. So what are the techniques? There are 7 techniques. So the first one would be power rule, the second one would be product rule, the third one would be quotient rule, the fourth would be chain rule, the fifth would be sum and differentiation, the sixth implicit differentiation, the seventh logarithmic differentiation. So first of all, the power rule. So power rule is used when you differentiate x power of n. So the formula would be d over dx times x power of n. You will get n times x power of n minus 1. For example, x power of 4, you will get 4 times x power of 3. So basically just bring the power down and minus the power by 1. Next, product rule. Product rule is used when two functions are multiplied. If y equal to u times v, then the formula would be y prime equal to u prime times v plus u times v prime. Example, differentiate 3x times 3x power of 2. So first of all, you need to basically differentiate the first, keep the second, and keep the first back, differentiate the second back. So basically you just need to differentiate the first form of u power u prime times v, and then you need to differentiate back the second. Next is quotient rule. Quotient rule is used when function is divided. If y equal to x, sorry, u over v, then the formula would be y prime equal to u prime times v minus u times v prime over v power of 2. So basically differentiate the top and bottom using the formula. The fourth would be chain rule. So when we use chain rule is used when one function is inside another, basically a composite function. So basically the formula would be dy over dx equal to dy over du times du over dx. So basically we want the dy and dx, but in dy there's the power over du, there's du under, so basically we need to estimate the du to get the dy and dx. So basically it is differentiate the outside first, then multiple by the inside derivative. Sum and difference rule for the fifth. It is used if you add or subtract functions. It is differentiate each separately. So basically, for example, x power of 3 plus 5x, you want to differentiate this, you will get 3x power of 2 plus 5. So you need to differentiate each of the functions separately. It is very simple. The sixth would be implicit differentiation. It is used when y and x are mixed and you cannot make y the subject easily. For example, x power of 2 plus y power of 2, you will get 25. It is differentiate both sides, but whenever you differentiate y, multiple by dy dx because y depends on x. So next, the seventh would be logarithmic differentiation. Logarithmic differentiation is used when the power contains a variable like x power of x power of sin x, or 3x in the column power of x. Take log on both sides, then differentiate.
Hello, I'm Adif.
So
I
that's all
want to
from me.
explain how to
Thank you.
solve this equation. Alright. The first step, you want to different both sides of the equation with respect to x. Next, apply the product rule and chain rule where necessary, so you can get this answer. Alright, the next step, rearrange the equation to isolate dy over dx term. Next, factor out dy over dx. And the last step, you want to solve for dy over dx by dividing both sides. So you can get this answer.
Question A. Number 1. Apply the chain rules and derivative rules for trigonometric and logarithmic functions. dy over dx equals d over dx tan 5x plus ln 2x is minus 1 bracket square. Number 2. Differentiate tan 5x. The derivative of tan u is 6 square u multiplies du over dx. Here u equal 5x, so du over dx equal 5. D over dx tan 5x equals 6 square 5x multiplies 5 equal 5 secant 5 6 square 5x. Number 4. Combine the derivative. Divide over dx equal 5 6 square 5x plus 4 over 2x minus 1. That is the answer. Number 3. Differentiate ln 2x minus 1 in bracket square. First, use the power rule of logarithm. Ln a power b equal b ln a. Ln 2x minus 1 bracket square equal 2 ln bracket 2x minus 1. Now differentiate 2 ln 2x minus 1. The derivative of ln u is 1 over u multiplies du over dx. U equal to x minus 1, so du dx equal to dy over dx in bracket 2 ln 2x minus 1 equal to x 1 over 2x minus 1 multiplies 2 equal 4 minus 2x minus 1. Question B. Number 1. Apply the question rule given y equal u over v, where u equal. Question B. Number 1. Apply the question rule given y equal u over v, where u equal in bracket 3x minus 1 square and v equal in bracket x plus 2 power 4. The question rule states dy over dx equal v du over dx minus u dv over dx over d square. Number 2. Find du over dx. U equal bracket 3x minus 1 square. Using the chain rules, du over dx equal to bracket 3x minus 1 plus 3 equal 6 bracket 3x minus 1. Number 3. Find dv over dx. V equal in bracket x plus 2 over by 4. Using the chain rule, dv over dx equal 4 in bracket x plus 2 square root multiplies 1 equal 4 in bracket x plus 2 square root. Number 4. Apply the question rule formula. Dy over dx equals in bracket x plus 2 powered by 4 multiply 6 in bracket 3x minus 1 minus in bracket 3x minus 1 square multiplies by 4x over in bracket x plus 2 over by 4 in bracket square. Simplify the expression, factor out common term where x plus 2 square root and 3x minus 1 from the numerator. Divide over dx equal x plus 2 square root in bracket 3x minus 1 in bracket 6x plus 2 minus 4 bracket 3x minus 1 over in bracket x plus 2 powered by 8. Simplify the term inside the bracket 6 in bracket x plus 2 minus 4 in bracket 3x minus 1 equal 6x plus 12 minus 12x plus 4. So divide over dx equal x plus 2 square root multiply in bracket 3x minus 1 in bracket minus 6x plus 16 over in bracket x plus 2 powered by 8. Cancel out in bracket x plus 2 square root from the numerator and denominator. Divide over dx equal 3x minus 1 in bracket minus 6x plus 16 over in bracket x plus 2 powered by 5. Number 6, expand the numerator. In bracket 3x minus 1, number 6, expand the numerator. 3x minus 1 multiplies minus 6x plus 16 equal minus 18x squared plus 48x plus 6x. So divide over the x equal minus 18x squared plus 54x minus 16 over x plus 2 bracket powered by 5. That is the answer.
Hello everyone, my name is Hazim. Today I will show you how to solve this question. The question is, use linear approximation to estimate the value of square root 2.99 plus 1 plus 2.99 per power of 2. Correct to 3 decimal places. Before we want to solve this question, we have to know the formula for this topic. The formula is